Welcome. This video we're going to walk through basic socket connections in TCP/IP and give you a couple commands to troubleshoot and verify connectivity. Understanding the connection in the socket is vital and important when you're ever troubleshooting any type of connection, configuring a firewall, wondering what your computer or another computer is doing. So let's start here with an overview. I have a couple illustrations here. And at the top, this first rectangle is basically what we're looking at. We're looking at a client connecting to a server. Example, a client could be a phone, a laptop. It could be anything, really. What's defined as the client is who sends the first packet. It doesn't mean it based on the operating system or something. For example, the client could be a Windows 2012 server connecting to Microsoft to download something. Again, who initiates the connection, who sends the very first packet becomes the client. A server is something that's receiving it or hosting a service. An example is a web server, an FTP server, an email server, or something like that. And again, to be a server, you simply have to be running a program that supplies access to that service. It doesn't have to be a server operating system. An example is a Windows 7 or a Windows 8 or 10 can host a web server. And it's actually one of the features that's built into that operating system, so it allows you to build little websites and stuff right on your computer. So that's the first concept. The second concept is to understand what makes up this connection. And that's the second rectangle here. The second rectangle illustrates that the client will be running an application of some sort. It could be a command line. It could be a web browser. It could be an FTP client. It could be Outlook. And it uses the IP address or one of the IP addresses on the computer. Usually clients will have one IP address. And that IP address will use a port number and a protocol. Now this box in blue box, when I teach networking type technologies, is actually two pieces. It's a transport protocol, TCP or UDP, and then it's a port number based on that transport protocol. But we're just going to deal with this as one object for a day. So basically, you're going to be connecting, for example, if you're connecting to a website, it uses TCP. And the number it picks here at the client side is most often random. It's going to be random above the well-known range of 1 to 1024 or 1023. And it's going to be a number above 1023 up as high as 65535, which is the highest number in a 16-bit number. So we can have ranges from 1024 to 65535. And what the computer does is the client picks a number based on tying it to the application. So when you open a web browser, for example, and you point it at Google, and you open another web browser or another tab, you point it at Google again, each one of those windows in that application will get a different random port. And that's so that when the request goes out to Google to get the website, it knows what window or what application or what tab in your application to give it back to. So that's pretty much how the client's handled. The connection goes out. There's something called in TCP a three-way handshake. We're not going to get into that, but basically there's a sense of communication that establishes connection. So just like if you went to the local township store, local township building, I should say, and you need to get a permit, you would go to the counter that issued permits. So clients connect to the service that they're looking for. A server, for example, might be running multiple applications on that server, FTP, email, and web, for example. And you're going to want to connect to the port it's listening on, and it's called a listener, to make sure that you connect to the correct service so you get what you're looking for. The server, just like the client, uses an application. The application uses the IP address, and the IP address uses a particular protocol and port number. In the case of a web server, you might be running IIS on Microsoft server platform. It's going to use the IP address of the server that you assign to it. And again, servers, you might have more than one IP address. For our example, we'll just use one. And the port would be port 80. And if you wanted to support HTTPS as well, encrypted web surfing, you would also support 443. So I'm not asking you to remember the port numbers. I'm simply just trying to show you the connection information on the server side. So when we refer to a socket, we're referring to the IP address and random port on the client, and the IP address and the service port on the server. And we're going to show you some of this. So we're going to go down to the next rectangle here, and this rectangle is going to break these into real numbers. An example would be a web browser. Maybe my client has this IP address, and maybe it randomly chooses 12351 as its port, sends a connection to a web server, let's say Google. It sends it to this IP address, and there's a little bit more in there to get to that IP address. There's something called DNS, but we're not talking about that here. DNS will ultimately tell your computer this IP address so you can make the connection, but we're assuming that all happened already. So you'll connect to this public IP address of Google on port 80, because that's what the service you're looking for. And maybe it's a Linux box running Apache, or maybe it's a Windows box running IIS, whatever it is. And it would host your website, and it would provide the web page back to the client. Down here, we take it into a little more higher level, what would you see? So I would open a browser on my Windows box, okay? The communication that makes all this up is called, we call it a stack, but you can think of it as a language. It's called TCP IP, and that is the protocol or protocol suite that allows an operating system or computer to use its network card to talk to other things. Now, there are other suites out there. We're not going to be discussing those here. This is the de facto standard across the planet today. It uses a network card, whether this network card is built in, wireless, wired, whatever it is, to get you on your local network there and get you out to a network if you're at work, or an internet connection. And we'll just refer to that as the cloud. And then somewhere out there, the opposite is true, where you have another network card attached to this physical server. It uses a TCP IP stack, and it's running an operating system, and I've just illustrated it here with Linux running Apache, Apache being a web server product. So hopefully that shows you a little bit about the basics of connections. So let's go to our next slide here and talk about how do we view connections to know if they're working or not. And we're going to be doing this live at the second half of this video. So I have a slide here that takes the rectangle we've been looking at and breaks it down. Now, this command, I'm going to show you how to issue this command to get these results where these numbers are being seen. The command is called netstat. We're going to show you that on the next page, but netstat will list out all your connections. And typically, between the address you see in the red box and the port number you see in the cyan box, there's a semicolon there, but in this command line, it only shows a period. So it might be a little confusing. Some operating systems between those numbers show colons, some show periods, but basically the way it breaks down is this was from a Mac, by the way. This was taken off my Mac. I opened the web browser. This was my IP address. You can see it here. This was the port number it picked. Now, this one doesn't match, but I'm just showing you it picked a whole bunch of random port numbers for different connections. The destination it went to was Google, and the destination port it went to was port 80. And I don't know whether Google's really running Linux with an Apache web server. I just use it as an example. So it's possible to see these connection bits from within a terminal or command line, or within some GUI utilities as well. And when we see them, a lot of these utilities will show a state. There are different states. Established means you have a connection. Closed wait means you're breaking the connection down. Maybe you'll see something that says like SYN sent. That means you sent the connection, but you didn't get a response yet. So there's a bunch of different states here to show you what they are, and they're very easy to Google and look up on the internet. For the most part, if you see something that says SYN sent, that means you're waiting for the server to respond. If you see established, it means you have a connection. And if you see close wait or time wait, that means it's waiting the timeout or close out the connection, which can take up to a few minutes. So hopefully this shows you a practical way of looking at what we're talking about here in theory. So let me bring up another slide here with a netstat command. This is the one we're going to be using in our demo today. Netstat is built into every operating system. It's part of the TCP/IP stack itself. And what it does is it simply lists connections, and you get different options. So in the sense of just typing netstat by itself is a simple command, and it shows you live connections that you have in your computer, regardless of the state. The only state it doesn't show is listening, which I'll explain in a moment. So if you had some connections that were established and some that were breaking down and some that you were just starting up, they would list them just by typing netstat at a command prompt or a terminal, and it would list them all out. The only thing I don't like about this is it tries to use fancy little fun names. So you'll see here on this side, it told me it's TCP. It told me my IP address, which would be the local address. It told me what random port my computer chose for this connection. On this side, it chose something goofy, some goofy name it got from somewhere. It's actually from reverse DNS protocol, but it doesn't really help us, and it doesn't really let me see what I'm connecting to, and it's quite confusing. And then it says HTTP, but I really want to know what port that is. I want to know the number, not the pretty little protocol. So just typing netstat without any options does this, gives you this naming in here and this resolution. It tries to be smart and figure out what you want to see that's more readable, but a lot of times it's not. It does give me a state. So what I did is I ran the same command, netstat. I did a space and then a dash lowercase n. And that means numbers. Don't do this. Don't give me the pretty little names. Give me only the numeric values. It actually runs a lot faster because this process of taking the number and trying to figure out what this name is takes time. So when you run netstat space dash n, it's not going to try to do any name resolution or number resolution to figure out what these should be. It's simply going to show you the same thing in numeric value, and here you see it. It's a TCP protocol, my IP address, my random port number, the IP it's connecting to, and the port number. So 80 is HTTP, but I get to see just the number and our state again. So this is one I use quite a bit. Now, netstat with just the N only shows you connections that are either established, building up, or breaking down. What if I'm on a server and I want to see if, for example, my web server is running and listening and waiting for connections, okay? You would have to add the A, means all. And what that does is it shows you all ports, even if they're just listening. A listening port is something that's waiting for a connection to establish. It's waiting for a client. And even though you're on a PC or a laptop, you have running listeners for things like Microsoft on ports 135 and 443 and a bunch of high-level stuff. So let's take a look at this. Ran the netstat command with a dash AN. I see protocols. I see local addresses. For example, down here is my local address. This was run on a different computer at a different time than this one was, but you can see my local IP address here. You can see that same session, the same port number, 49171. You can see its connection to that web server on port 80. And by about the time I ran this command, it started to close the connection. You can see it's closed wait. Web pages don't keep constant connections. I mean, you might sit there, open a web page and read it for 10 minutes. That server's not going to maintain that connection. It only connects enough to give you the web page, then it kind of drops off, unless, of course, you're streaming YouTube or something. So this is that connection, but you'll see a bunch above it, which are interesting. They all say listening, and they don't list an IP address as the local, and they don't list an IP address or a port as the destination, and that's because these are like service desks at the township building. Somebody sitting behind a desk waiting for somebody to come in the door and ask them for something. So in this case, the first one is TCP. It's listing on the local address. That means all of them. And this computer only has one, but that means it's listing on any of them. And it's listing on port 135, which is a Microsoft NetBIOS, NetBEUI type, not NetBEUI, NetBIOS type port, as is 445. These are two Windows-based ports used for Windows communications between computers. The foreign address is 0 because nobody's connected to it. That's the listener, all right? Now, if you actually had a connection come in, this line would remain exactly as it is, but another line down here would pop up with TCP, your IP address, port, let's say 445, the IP address of whatever connected to it on port 445, and their address, and it would say established. This listener remains because it's listening for another connection, and as we might imagine, services can handle more than one computer connecting to it at a time. So that's the fundamentals of doing netstat. We're going to do a little bit of this live and show you how that works. And finally, I'm going to show you one oldie but a goodie. This has been around for 100 years, so it seems. But it's a graphical user utility that you can download from nearsoft.net called cports. It stands for current ports. And the neat thing about this is it gives us the same data but in a GUI format. It makes it easy for us to right-click and disconnect something. It also has some great features as auto-refreshing and logging, so you can keep it running over time and see what changes. But one of the best features I find is it tells you what application is using that port, where if we look at these ones, they don't really tell us what applications are using these ports. So for example, here in the screenshot, you'll see the IP address of my machine, the random port it picked, the web server it was connecting to, the web port 80, but you'll also see Internet Explorer and the particular instance of Internet Explorer on that machine running under the process ID 3024 is what's using that port. And if I had a problem with that, I could either right-click and kill the connection here, or I could go into my task manager in Windows and find the process ID 3024 and kill it there. So it's kind of neat that way. You get to see what application's actually using it. So that being said, let's go ahead and give you some demos on this and show you how to test a connection. So I have a couple different things for you today. This is a terminal screen. I know it's black on black here. So this is a terminal screen on my Mac. So I'm going to do a netstat, just hit enter, and you can see it. It's going to give me a lot of stuff. I'm not going to let it run through all the list, but these are some connections it actually has open, and my computer runs code 42 crash plan, and you can see my computer has a random port here, my IP address, and it's connecting to crash plan on HTTPS. Now, if I did that with a -n, and again, I got way too much data there. Sorry about that. This is just you can see how much faster that was. Now I got to go all the way to the top here, and there it is. When you do it by name, it doesn't stop to figure out, when you don't do it by name and you do a dash number, it doesn't stop to try to figure out all these connections. So on that first one, the port number was 55898. 55898 is no longer there. Where is it? It must have died off. But here's one, 55857, and this is going to FFAV. I don't even know what that is. But here it is again, 55857. So this is the same connection as this. How can you tell? Because only one connection can use the IP port combination of all four of those pieces. That's called a socket. So only one application can use 192.168.250.100 on my local machine with the random port of this and connect to this site on port 80. I can't have two applications do it. If I launched a second application, it would have picked a different IP. So you can see how much better, let's just say, the -n is. And then if I want to list all the ports, I can do an AN. Now what I'm going to do here for real quick, I'm going to put a little gap of stuff so that I can find it, because it's going to go by really fast. Netstat -an, and I hit enter, and it did go by fairly fast. I'm going to scroll up. There's a lot going on this machine. It's a long story, but that was the first command. I should have cleared the screen before I ran the second command, but we'll find it. It's going to be about halfway down here. There it is. So this is the beginning of my other command. And we can see all the established. You can see there's some listening ports here. Not a lot of them. I've got something listening on port 631, something listening on 55409, and I'd have to look up what those are. That being said, let's go ahead and take a simpler look at this, which is I have a server and a client. That's my client. That's my server. So this is running Windows, and I think it's 2012, and I'll log into this. And this one is a client, I believe it's running Windows 7. So if I want to do the same thing here, I can do a netstat, and you'll see it'll show connectivity. This one will probably have a lot less because this is a very plain Windows 7 machine. So you can see there's a connection between it and something on 102 on port 1400. I'm going to stop that. I'm going to do it with a -N, and we'll see how much faster that is. Oops. We don't have anything running right now. So nothing. Let me open a connection here. Let me start over. And if I do netstat -N and I get nothing, that means I have no connections. When I launch this and I go to google.com, wait till that loads. And now I show the connections. Now just loading google.com opened 4 different sites. And you can see some of them are HTTPS, some of them are port 80. And they're established. And then if I kill this window, they go away. Sometimes they linger a little bit longer, okay? If I open it again, they're back. And they might be different destinations because Google tries to load you all over the planet. Now, if I want to see the ones that are hosted on this machine, I go netstat-an. And now I can see a lot of listening ones here. For example, 135, 443, they're used by Microsoft. You'll notice on the left-hand side the protocols. So there's 2 different protocols. Typically, you'll see TCP and UDP. Depending on the type of application, it will use a different type. And then you'll also have some numbers that are real long like this or short with double colons. And then you'll see some others that are numbers separated by dots. And that's the 2 versions of TCP/IP. This is version 6. This is version 4. 4 is the most common, but the world's starting to move towards 6. So don't let that confuse you. For right now, if you just use 4, which is the one where you see the something dot something dot something dot something, that is the IP address. And then you can see here, Windows actually puts colons to separate the IP address from the port. So it's this is, for example, 192.168.250.143 is my IP address, and the random port it chose was 49302. And this is connecting to this web server on port 80, and it is currently running. So if you're ever wondering whether you have a connection or not, that's one way to check. See what the status of that connection is. If I connect to something like this, I'll try to make it fail. 1 to 2 to 3 to 4. That probably won't work, but I can try to find it. So here you go. I try to make a connection to something that's probably not a web server on the internet, and it'll probably time out and never get there, but you can see the socket tried to establish TCP, my IP address, a random port trying to connect to 1.2.3.4 on port 80, SYN sent. That means I sent a packet out of this machine, but it never ever came back. Indicating that either it was blocked on its way to the server, or the server is not running that service. As a firewall and security engineer, network engineer as well, I often get, well, you're blocking something. So the first thing I like to do is say, go to the server and do a netstat-an and see if you're listening on the port 80. If they do that and they don't see anything listening on port 80, I'm never going to connect to it anyway. So fix that first. So let's go ahead and show you how that works. I'm going to take the server. Now, this is a server that's running a web server. So I can tell that because if I do netstat, and I'm going to not let that finish because a server's going to have a lot more, but you can see it's hosting on port 80 right here, which means it's a web server. The web server software on here is the built-in stuff that Microsoft provides for you. And I can actually show you that too. Let me do that so it's not such a mystery for anybody that doesn't have experience doing it. So this is, you just say add a role and say I want a web server, and it puts this software on there. And you can see I have a website here. And let me just go edit bindings. You can see it's hosting on port 80. And an app guy or gal might say, oh yeah, my web server's installed, but is it listening? It's not listening. If I was to stop this web server right here, and I stop it, when I look at the listeners, I'm going to do more here so it doesn't page through too much. You can see port 80 is gone. That says 88, by the way, if it doesn't show up in the video. 80 is gone because the web server is not running. So if I'm trying to connect from the client to here on port 80, and somebody's telling you they must be blocking it somewhere on the network, first make sure this is hosting port 80. Also make sure it doesn't have a firewall built into this operating system. So when I start it again, you can see it's back. And now I could technically connect to it. I don't know what IP address this is. 250.250. So because it's there, I should be able to connect to it. 192.168.250.250. And I can, look at that. So applications drive what things are listening. So what I'm going to do here is I am going to add another role to show you how an application is just a piece of software. So here's my web server. Underneath, there's also an FTP server for transferring files. So I'm going to go ahead and add that, install that software. And again, how you install your software on your computers, there's lessons all over the planet on that. But this just kind of shows you that if I install FTP, the FTP service should run on port 21 and technically port 22, also 20. And let me see if it's running. So I've installed the software. And no, it's not running. Look at that. I've installed the software, yet I have nothing working. So this is not uncommon to see in the field. Hey, we installed software, but it's not working. Okay, well, let's take a look at why. Let me just run it one more time. Not running. So let's go into this software where I can manage it here. I think I got to close this and add it again because I just installed it. So IIS Manager happens to be something that also manages websites and FTP sites. And I still only have one site under here. I'm going to add a new site. Test 2. We'll go into this default folder they give us. Port 21. We're going to say no SSL. You can actually do secure FTP, which is better, but we're not doing it. We're going to allow anonymous. We're going to allow anonymous users to read. And we'll see if that works now. So it looks like it actually authenticated this time. Let me put something in the folder so we can see it. Let's do a new text file. So we have a file in there. Let me just refresh this. And you can see the FTP is up, and I can actually open it over here. And then we should show the connection over here. And you'll see we have a connection between the client on the random port to the server on the port 21. And over here, we can do the same. And we do have a connection between our server from port 21 this time because we're the server side to the client to its random port. So it's the inverse. So hopefully that shows you a little bit about how to set up a connection. I'm actually glad we had a little bit of problem there with the FTP. I'm going to leave it in this video because it's good troubleshooting. And we showed you how to install a service so that you could actually set up a server and how servers and applications provide port numbers that you connect to. Ultimately, this is your socket right there. This is the server side way the socket looks because the server has the static port. And this is the client version of the socket, where it's from this IP address, from this random port to this destination address to this physical port on the server. So I hope you enjoyed it. It was, again, meant to keep kept simple for people who don't usually work in the networking field to be able to troubleshoot some of their connectivity. Appreciate you watching. Thanks. Bye-bye.